actually record this, so that way we can post it later for anyone who wasn't able to attend. So just be mindful, you are being recorded, so all the fun stuff. But welcome everyone to our third or second virtual meetup. So it's taken us a few tries to do this. So we're trying a new thing, Zoom. This is our first Zoom one. So we're hoping that you all enjoy. Please feel free to give us feedback on any improvements that we can do. My name is Cynthia Wu. I'm one of the organizers for dcast. And so just to give everyone a little bit of feedback or give everyone a little bit of context of what dcast is, it's a local meetup around testing. We try to keep it local because, I mean, there are obviously global groups out there like the Ministry of Testing and CAST, but we found that DC has a very specific need of testing because we work so closely with the government, and government doesn't always change as fast as we want it to. So we have our own set of problems that we deal with. So we felt, having something that was more local to really tie into our needs was something we all wanted, and established a community. I think all of us have felt isolated at one point in our careers, especially here in the DC area. So we're hoping that you can use dcast as a resource for you all to reach out to other people in the quality engineering field. So in dcast, I am joined by 3 other organizers, Jean Godmer, who actually set up this Zoom, Peter Kim, and Jennifer Galvin. If you ever want to reach out to us, you can find us on dcast.io. A lot of that information is on meetup.com. If you ever want to reach out to us, that's actually how Dhaval actually found us. We are always looking for presenters and speakers. So if you have a topic that you feel really passionate about, that you want to share, reach out to us. We're always looking for talks. And it's best when it comes from people here in DC. And with that, I'm going to pass it over to Dhaval, who is going to share with us his presentation of Shifting Left.
Okay. Well, thank you, Cynthia. Welcome, everyone. I have been, well, first of all, let me say my name, Dhaval Shrimanker. I've been in DC area for 17 years now. I moved from Dallas, Texas. That's where I did my undergrad. So a big Cowboys fan here in the Skins country. And a lot of DC folks are Dallas Cowboys fans anyway. So just felt right at home. I see Sharnice shaking her head, and so does Cynthia.
That's really brave of you to say. Well, so.
Yeah, but no, it has been fun. I do love football, and I think if you spend whatever amount of time in Dallas, you don't have much enough of an option but to love football, because it is a big football country. Even besides Cowboys, they're big into college football as well as high school football. So anyway, that's a bit of a background about me. My degree is in computer science. I've played various roles over my career. Started off as a developer, and at one point just got sick and tired of sitting in a cubicle for hours and hours and hours crunching code. And then the worst was the deployments that really got me, and then I moved into QA. A lot of people go take a reverse path. They start off with QA and move into development, and I was just burnt out in the development field. So I got into QA, and I loved the whole field, and just ensuring that I was part of something big when it came to delivering high quality product. The buck stopped on me, so the feeling was great. So that's me. And then lately, over the last 10 years or so, the whole DevOps movement has picked up steam. These days, it's very prevalent, and most of us who are in DC area, you will see more and more work coming in the DevOps realm. A lot of the folks are looking for test engineers with some coding background, and I'm pointing towards automated testing. We have a large bank headquarters here. I won't take their name, but you guys probably see their big tower of a 495. They love to hire software development engineers in test. They don't hire straight out engineers. Well, they do, but they emphasis on that test portion. If any one of you is working there or have tried to get into a technical position, they will ask you a lot of questions about testing from processes and whatnot. So, and then we have two behemoths here. One is the federal government. The other ones are the Fannie and Freddie's, who also have massive, massive programs around testing and the overall QA. So we're going to talk a little bit about somewhat of a high-level overview as to what it means to be a QA in DevOps, and what does shift right mean, and how do we tackle the whole testing aspects in DevOps. Okay, so that being said, I will share my screen, and I will request just maybe Cynthia, you can quickly let me know if you don't see my screen, and share this one. Okay, great. We're using Zoom. Okay, fantastic. And if you see me with my head turned around because I have a different monitor that I'm going to keep an eye on. If anybody's putting any questions in the chat window, I'm not ignoring you guys. Okay. Um, the other monitor is the one that's where the slides are going to be in presentation mode. And slideshow. All right, and I'm assuming you all can see my slideshow now. The title slide. Okay, so welcome to Continuous Testing in DevOps. Initially, I had titled this Shift Left and Shift Right in DevOps, but I figured that it spans all the way end to end, so I figured I'd rename it and call it a Continuous Testing in DevOps. Okay. That being said, I'll kick it off. So kick it off with a disclaimer, okay? This presentation and the views in this presentation are stemming from my experience, and I've supported various testing and DevOps programs, and I continue to do so as of today. So the views does not reflect of my employer, which is the Ambit Group. I work for Ambit, but these are strictly my views, okay? So here's a bit of an agenda today. We're going to talk a little bit about the traditional model, which most of you must be familiar with. We're going to talk a bit about what is shift left, what is shift right, go over the agile and DevOps models, jump into continuous testing, and I'll talk briefly about how to go about this whole continuous testing, how to go about shift left and shift right. Okay. All right, and note. So, no automated testing, no DevOps. Okay, if you're strictly a manual testing shop, you cannot accomplish what DevOps has to offer. All right, so just bear that in mind, and we'll kick off on that foundation. So, what is a traditional model? I think many of us are very familiar with this. It looks waterfallish, and it is waterfall model, basically, where the requirements were gathered, analysis was performed on those requirements, which eventually turned into a design. The design was handed off to the developers. The developers turned it into code. Once a product or whatever was built, was handed off to the testers. And once the testing was completed, let's assume everything passed. And then the bundle was handed off to the operations for deployment. And what happened after deployment was a mystery because it was a completely separate group in the operations side, right? So from out of the DevOps, let's consider all the way from requirements to test was dev, and then the operations is the op portion, right? And the testing was rather limited only to the code, okay? The testing occurred really, really late from a timeline perspective. If the requirements were kicked off, requirements gathering were kicked off in January, testing probably happened in November. Okay, just to put it in perspective in this hypothetical scenario. And testing was only limited to the code. So everything that was coded was tested, or most of it was at least tested, right? The problem with this model, most of us again probably are aware of it, that the requirements were never tested. And some people will question, well, why do I need to test a requirement? A requirement is a requirement. We need to build it, right? And I'll get to that portion as to why the requirements need to be tested. Okay, so this is pretty much on a higher level what a traditional model looked like. So continuing on traditional model, there are the disadvantages. And by the way, I just wanted to put it out there that I'll share the slide with Cynthia after the presentation, and she'll be happy to share it with all of you. Okay, so the reason for mentioning that is I'm not going to read everything on the slide, but just on a high level, I want to mention, right? The testers were, most likely never involved in the initial planning phase, correct? So if you've ever been a project manager, you probably realize that you've had to forecast resources. How many testers would you need to test the product? You can't forecast as to what is this going to turn into. 10 months, 11 months in advance, correct? So there was a challenge. The requirements, the architecture, and the design, if any of these were erroneous, if any of these had defects, they wouldn't be uncovered. Even if they were uncovered, it would be really late. A lot of resources, time, effort, money, everything has been spent in the gathering, the analysis, the design, and the development as well, right? And plus the testing. So going back and fixing them was very, very costly. If defects were identified in the hypothetical scenario, as I mentioned, out in November, and you have a milestone of delivering something in December, the developers have to go back and start debugging, and it became very challenging, right? Time for testing was always little. Testers would always complain that, oh, we don't have enough time to test, or there was an expectation that, hey, you're a tester, you can test 24 hours a day over the next 2 weeks, right? So those misconceptions. And then whenever some defects were found and the developers agreed that we're going to fix these defects because the management decided that if these defects went into the production, it would be a disaster. So these defects must be fixed, but the deadline isn't shifting much or at all. So that led to developers cutting corners, creating fixes that were really fragile, leading to larger technical debt. Correct? So here we are in DevOps world these days. People look forward to the automation and everything. And with that coming into the picture and Agile coming into the picture, the testing has somewhat shifted to the left, right? So what is a shift left testing? Most of us are working in Agile construct these days, so you're probably familiar with this diagram wherein you're working on features or user stories. When you've got a user story, the story is groomed in your backlog refining sessions or grooming sessions, which then eventually turns into code and it's tested, and then it's deployed, and again, going into the operations, right? So what happens during the grooming phase specifically, right? The whole team is involved in the backlog grooming session. At least I hope so, that whatever team you guys are working in as QA personnel, as testers, that you're involved heavily during the backlog grooming or the refinement session. And you have a say. When you look at a story, that story is coming from a user perspective. So you as a tester, you're thinking from a user perspective that I as a user, what are the steps I'm going to perform on the application? And then you test accordingly, correct? So that's what I mean by shifting to the left. You start off testing your assumptions and whatnot all the way when the requirements are in a story phase. Okay. So on a high level, shift left testing, just an approach to software testing and system testing in which testing is performed earlier in the life cycle, right? From a timeline perspective. Hence, it's moved to the left on the project timeline, right? So anybody who's involved in DevOps these days, you probably realize a lot of people will say, you know, test early and test often, right? Don't wait for a one big bang testing phase. Have this continuous testing as part of your strategy. So this is the first half of that maxim. Shift left, test early. Okay, so that's on a high level shift left testing. Then climb, as of last, I want to say at least 5 to 6 years, and probably in commercial sector more than that. A lot of the folks have moved into shift right testing, or at least I know for sure Facebook has been leveraging shift right testing techniques for a while, definitely over 10 years now. Okay. So once again, the same diagram, you've got your user story goes through the grooming, coding, testing, and deployed to the production where the operations comes into the picture, right? And now if you can see that the red arrow has shifted on the operations side. So what does that mean? That means the testing is happening in production, okay? Now don't be alarmed that testing is happening in production. Means you're adding a load or stressing your system out. There are different techniques, and it's a little different than what the traditional testing looked like. Okay, but just from a concept point of view, from a definition point of view, shift right testing again is an approach to software testing and system testing in which testing is performed in production. And in the parentheses, I've put in active or passive environments, and I'll talk about that, what I mean by active or passive environments. Okay, so that's in a nutshell, shifting the testing to the right. Okay. Agile model. Most of us are pretty familiar with these loops these days. These circles have become innocuous in our careers. So the question arises, if you are in an agile model, when do you test, right? You're in your sprint. Let's assume a scenario you're in sprint 1. The story has been groomed. It is being developed. But when do you test? Towards the end of the sprint? Or, hey, today's a Monday. A story was developed and the developer reached out to the tester that, hey, I have developed this user story. Go ahead and test it. And then the developer moves on to developing user story 2, correct? And then the tester can say, hey, I've completed testing my user story 1. Let me know when user story 2 is ready, right? And 3 and 4 and so forth. But now you need to perform integration tests of these user stories. If there's a flow that covers user story 1, 2, 3, 4, 5, when do you test the end-to-end integration test, right? Do you test it within sprint 1? What if you don't have time? Because the developers are not going to sit idle. They're going to continue developing till the last day of the sprint, correct? So, and you as a tester, you're testing till the last day of the sprint, but your testing is limited to the user story itself. So the question arises is, where do you execute your integration tasks? When does these user acceptance tests come into the picture? Where do we perform or execute the performance tests? between sprint 1 and 2, or between sprint 2 and 3, or after sprint 3? When is the question, right? And we'll leave it at that for now. The answers will come as we progress through the presentation. DevOps model, again, everybody, or at least most of us, are familiar with the infinity loops here, wherein you start off with the planning, you jump into coding, you build, you test, you release into the production, deploy out there. It's in the ops portion, kicks in, and then the monitoring phase comes in. The operations generally looks into what the application is doing. You have created a new application, or you've added new features into your existing application, and you have deployed into production. Um, what's happening? Let me give you guys an example. You have a car, right? You have an automobile, and you think that you want to add some features to this car. Let's take an example. All right, you got a Honda Civic out of a dealer, nice looking little vehicle, but hey, you want to make this car look like one of the sports cars in the movie Fast and Furious, right? So you're adding new features to your car now, correct? And let's say the mechanics, the garage guys, they fixed the car shop guys, added all these new features and delivered the car to you. Now you're gonna start driving this car. Immediately you're going to say, "Ooh, I love the performance at this point." So that's your monitoring piece, right? Compared to what it was initially, and compared to what it is now after the deployment. And you're going to continue monitoring that, because all of a sudden your application is completely different than what it used to be, and there are all these new features added. So you want to keep an eye as to how this is performing, right? So that's where what the monitoring piece is all about in the DevOps model. But the same questions arise, right? If you are in a DevOps model and you are continuously testing, now remember, you've got automated tests here, okay? You're not manually testing. Um, Maybe a little portion of it you could be assigned to manual tests, but for the most part, right, these are automated tests. So when do you run your integration tests? And the same questions arise: when do you run your user acceptance tests and your performance tests? So that leads to the continuous testing, right? So we've done shift left testing and shift right testing, aka continuous testing. We're going to run our tests on a continuous fashion. And what do I mean by that? Right? And this is what I mean. All right. So when we are in the planning phase, we're going through pressure testing our assumptions about the user stories. We're trying to identify whether this user story is a real need stemming from feedback or user data, or is this user story a pet project? If you have a product owner and the product owner just comes out and says, "Hey, I would like to have these," right? So there's a difference between a like versus a need, correct? And DevOps is all about supporting a need. Uh, of course, you will see from time to time that the users will provide insights to the companies or the organization saying, "Hey, we would like to have this and we would like to have that." That is from a user standpoint of view, but from the organization or the business standpoint of view, they need to be the ones to decide whether it is going to be a nice to have feature in their application or whether it's going to be a must have feature. So that's where what I mean by testing during the planning phase. Um, and then the code is created, right? Uh, and you test your code using your automated tests. And I'll talk about different types of automated tests in upcoming slides as well. When the code is merged, so if a developer A and developer B, they both check in their codes, what happens? You need to run your integration tests. Again, you have automated functional tests. They kick off and they test the integration of your application. The build is created. So the build um, basically gives the reports coming from automated tests will tell you whether your build is steady or not. Um, you deploy it to the production, and then again, the same cycle repeats. You start testing into the production, and then monitoring and so forth, and the loop sort of continues. Okay, so literally every user story that is developed is thoroughly tested. Multiple user stories combined together are thoroughly tested. They are deployed into the production, and once it's in the production, there are more types of tests you all can run to ensure and gather data about whether it's user behavior or whether how your infrastructure is responding, or what is your application doing with these new features. Is your application all of a sudden consuming more memory than it should, or has it opened up any unsecure any ports, making your network unsecure, and so forth? Okay. So a little bit of how, right? So shift left, test driven development. This is literally shifting way far on. If you remember the diagram where I had the feature and the bucket for coding and testing, those two buckets are covered using the test driven development. And what is test driven development, right? So instead of writing a code and then testing it, you're writing a test first. Okay, so first you write the test, and when I say first you write the test, you're writing code essentially. Okay, and this is part of an automated test. And test-driven development pretty much focuses on the unit level. So if you have a small function, a small class in your code base, then you're testing that one little piece of functionality, and that's it. Okay, you're not going through multiple steps in your total or overall business flow. You're just testing that small piece of your code. So hence it's called unit testing. So you write a test first and then you execute the test. Obviously you've written the test, but your logic code does not exist. Hence your test is going to fail. That's what the second point is. And then the third point is where you write the code. Okay. And once you write the code, you rerun the code, execute it again, and hopefully your test passes. And that's where it leads you to step number 4. Okay. Now, imagine if your test doesn't pass at step number 4, you kind of go back to step number 3 and try to fix your code. And then again, you execute, and at step number 4, your test passes, and then the developers get to refactor the code. And refactoring is a process where you enhance your code. The simplest example of code enhancement is if you have a code, let's say that took 10 lines, right? Can you shrink it down to maybe 5 lines or 3 lines? That's a very high level, simplest example. Okay. There are much better metrics to understand how to refactor the code. But just keep in mind, you're essentially enhancing your code, whether you're making it run faster in a short amount of time, and so on and so forth. Okay. So from a definition point of view, the test-driven development, it's a software development process that relies on the repetition of a very short development cycle. Okay, so just imagine you have a user story. The developer starts off with writing a test in that user story that executes the test fails, injects the code that goes in to not only pass the test, but to actually create the functionality, and then reruns the test or reruns the code. Hopefully the test will pass, and then gets into the refactoring cycle. And once that is done, that piece of code, that piece of functionality is checked in, and then the developer moves on to the second user story, and so forth, right? So it's a continuous short development cycle, right? So to expand the definition, the requirements are turned into very specific test cases, and then the code is improved so that the test passes. Okay. The benefits of test-driven development. Fast feedback. So if you look here, and sorry, I can't point to the screen right now, but let's see if my mouse pointer will show up. Okay. So you've written your test, you execute it, it fails, and then you write your code. And remember I mentioned that what if your test fails here? The developer instantly gets the feedback as to what the code is doing, okay? In comparison with traditional model, imagine the code was written and the developer moves on, right? And the developer hands it off to the tester, and then when the tester comes in and tries to test and says, hey, this isn't working, right? So a bit of a time has passed and there's a lag in receiving the feedback, okay? But with this test-driven development approach, it's literally between step 3 and step 4 is where the developer gets the feedbacks. And that's what I mean by receiving fast feedback, right? So in case if there's an error in the code unknowingly, the developer will get immediate feedback, okay? Forced to write small classes. This is a big thing. It's sort of from an software design or software architecture point of view, the smaller the class, the better it is. Um, just think of it as this way. You're creating a building using really small, tiny bricks, right? One brick at a time. So each brick's functionality is to be part of whatever, whether it's a wall or whatever you're building, right? A larger structure. Or consider Lego pieces. You will find plenty of tiny little Lego pieces, and when you put together, you can form something big, right? Somewhat of a similar concept wherein you write really small classes, and the idea of that class or their function is that it does one and only one thing. Okay, there's only one piece of functionality involved, and you know what happens with that is if somebody needs to change a class in their code base, they can easily do that without really impacting the larger system, right? Again, using the Lego example, if one of the pieces breaks, then all you need to do is just replace that one tiny little piece. You can still salvage pretty much everything that you built, correct? So that's where the flexibility comes in by writing these small classes. So you're kind of forced to write these small classes when you're using test-driven development, which results in very simple unit tests. And these unit tests can somewhat act as documentation in your code, okay? And because these use cases, these unit tests are, or these use cases are written as tests, the programmers, they can easily view the tests and try to understand how the code works. Okay, I as a programmer, if I were to leave a company and somebody else were to take my place, they can quickly look at the code base and they will understand really well as to what that one small class is doing. Okay. Some of the other benefits are that the bugs are reduced. Again, remember going back to that short feedback cycle, you will hardly have defects on the code front. There may be issues from the flow standpoint of view, but on the code front, you will almost eliminate your defects, okay? Which eventually leads into a better code quality, okay? And then there are some intangible benefits wherein the programmers are able to crank out code much faster, the volume increases, and a whole lot more. And the management may enjoy reading this bullet point where the development costs are cut, and your time to market is much, much shorter. So you can deliver your product to your end users in a significantly shorter time frame. All right. The next level beyond test-driven development is the behavior-driven development. That's what BDD stands for. Okay. Um, it's a development methodology based on communication. What is missing here is the piece called collaboration between the business customers, the developers, and the testers. Okay. So think of it wherein you've got features which are a feature have multiple stories, and now the stories go through the test-driven development cycle. Okay. And as these tests are passing, meaning you're finishing your stories, you're deploying your product. Okay. And then you move into the features. Okay. And I'll talk a little bit more about the behavior-driven development. It works really well if you are starting a product from scratch. If you have an existing product, it's kind of hard to bring BDD into the picture. You may, again, I'm saying may, depending on your code base, be forced to the TDD level. Okay. Um, so BDD, again, encompasses acceptance testing, highlights writing acceptance tests before the developers begin coding. Okay. Um, again, a lot of us are working in agile constructs. The term acceptance criteria is pretty much synonymous on a daily basis. Everybody wants to understand, hey, how good is this acceptance criteria? What does this mean? That means how good is your acceptance test, right? If your acceptance criteria isn't clear, chances are very high that your acceptance tests are not going to be good. Okay, and if you were to be leveraging behavior-driven development, the chances of having a success will reduce. Okay, so it's very critical that the focus is given on writing clear acceptance criteria. This is how it looks like. Okay, you start off on the left with the BDD. You have a user story. You put that user story through the grooming and pressure testing and whatnot, trying to understand that the requirements are clean. These are must-need requirements and not just like to have requirements. And you write an acceptance test, and it's obviously the acceptance is going to fail because there is no feature yet. It hasn't been developed, right? So from that, it leads into writing a failing unit test. So now we're in the test-driven development construct, wherein a unit test is written, then the code is written, the test is executed, the test is passing, gets into the refactoring phase, and at that point, your acceptance test passes. And once the acceptance test passes, you can deploy the code. Okay. This leads into automated regression tests. Okay. There is always an agreement between the business and the technical folks that the requirements have been clearly understood. Again, this is where the clear acceptance criteria comes into the picture. And you don't have to go in this detailed understanding of what the requirements are or what the feature is going to look like. Remember writing small piece of functionality that tests one and only one thing. The same concept applies to behavior-driven development tests.
I do have a quick question, which is,
Yes.
could you clarify what you mean by pressure testing? Because like, what is pressure testing and how is that different from stress testing?
Yeah, so pressure testing, you're basically challenging your assumptions in your requirements. Okay. Sorry, I haven't looked at the chat window here. It's in the, but thanks, Cynthia. So from a pressure testing point of view, you are challenging your assumptions. If somebody were to come up with a user story that, hey, as a whatever role, and I'm going to perform some actions so that I can expect some behavior. The question is, why are you developing that feature? Who made that decision? You as a developer, are you just going to blindly develop a feature, or are you going to somewhat question the status quo, right? That, hey, this particular, we're going to develop, as a business, you're going to decide that, hey, we're going to develop this particular feature because our users are asking. And here's the data that we surveyed X number of users, and majority of them are saying that they would like to see um, something happening on their website, or they would like to have the ability to perform certain things on the website, and that essentially turns into a feature and a user story. So that's what I mean by pressure testing. You're you know again, testing your assumptions when it's in the story grooming phase. Does that make clear?
Okay. Yeah, I guess like
Yep.
I struggle with seeing how like I struggle with seeing like how that actually formulates into like a test strategy or to a test execution in some way. Like we have like you've got like I understand like sort of stress testing because you're stressing your system. But in terms of pressure testing, like I'm not sure like how.
Yeah, so there is no official term called pressure testing. Just and you're not testing your system yet, correct? You're testing your requirements.
So like, is it more like going through based on the like when you're saying assumptions about requirements, are you
Hmm.
talking about like you receive the requirements and maybe there's even hinting at what the expected solution is going to be already included in those requirements and making sure that that's like feasible and practical and actually addresses the problem? Like, is that
Yeah, very well.
correct?
Yeah, very well put, Sarah. That's exactly what I'm alluding to.
Okay. Thank
Good.
you. Sorry,
Yeah,
I was like kind of trying to piece it together, but I was also confused. So thank you for
yeah,
asking the questions.
yeah. Absolutely. Yeah, great question. And Sarah, you pretty much summarized it really well. I'm gonna steal that if you don't mind.
Yeah, that's fine.
There is another question from the chat
Yeah.
from Anil about if you don't have detailed understanding, how can you write acceptance criteria?
Um, when I say you don't have detailed understanding of this large requirement or a complete end-to-end flow, you do understand the requirement of this small piece of functionality. Okay. I see that as a QA, you folks are thinking from an end-to-end perspective, right? But when you are writing automated tests, your tests are limited to this small piece of functionality. How can I give you guys an example?
I don't agree, but okay.
Well, okay. So here's an example, right? There is a login button, okay? Uh, so, or a submit button, correct? The the code that goes behind to support the functionality is when somebody, if you were to click a login button as a user, what does the system need to do? The system need to accept perhaps your username and your password and pass on that information to another piece of functionality whose job, or a class, and whose job is to verify that the username and password is correct. Okay, but the login buttons functionality is literally to take what the user has submitted and hand it off to another piece of functionality. And that's what I mean by not going into detailed understanding. Okay, so that's what I mean. A small piece of functionality, a login button's functionality is limited to what it needs to do. Okay, login button shouldn't be taking in the data of what the user is providing, such as username and password, then making a call to perhaps a database or whatever, retrieving the data from the database, verifying and comparing the user data and what's coming from the database, making a decision whether it's correct or incorrect, and then sending that data back to the user saying, oh yeah, everything looks good. Here's your dashboard. Yeah, here's your landing page. Or sorry, it's not correct. Try it again, or reset your password or whatever, right? So from a manual testing perspective, that's a thorough end-to-end test. I, as a user, I'm logging in. I'm testing whether I can log in and not. So, but from a automated unit testing perspective, okay, that login button functionality is very limited. Okay. All right, I'm gonna move on. Okay, so again, a little bit of a BDD and TDD, right? So I've been talking about creating tests, correct? So you start off on the left by creating tests. You run the test and check whether the test passes or fails. You have no logic code or persistence code yet, and hence the test is going to fail. So the next step is writing the code. You write the code and you repeat running the test. So you run the test, AKA you're testing your code. And once again, you check whether it passes or fails. If it fails, you go back to fixing your code or writing the code, and you rerun the test, and again, pass or fail. And this time, let's assume that it passes. Then you get into this refactoring mode, and then you rerun the test. Chances are it will pass because it has already passed. And then you check in the code. As a developer, you check in the code into the repository. Okay, so this loop, this diagram here is limited to the local development environment, or the local test/development environment. Okay. Let's shift a little bit further left, right, to the user story level, right? So if you're there, you're going to leverage, let's assume you're leveraging behavior-driven development, right? You start your test in a simple format, correct? You can use the Gherkin language. That means you're going to write your acceptance criteria in given, when, then formula, okay? What does that mean? So given a state of your application before a behavior is initiated, okay? So let's assume, given I visit google.com, right? So I am the user and I'm going to perform some action, so some behavior. So given a state, this is from a manual testing point of view, most of us remember there is always a field for precondition. And once that precondition is met, then you move on to the actual behavior. So given a state, you've met your precondition. When a behavior has occurred or an action has performed. So I am the user, I'm on google.com, right? So my precondition is met when I enter data into the search field and click search, correct? That is my when, that's my action when I click that search button. Then I expect a result due to my above stated behavior or above performed action, okay? So this whole given when and then is written in plain English, okay? I've got a very simple example here. This may not relate in your real life, but I just wanted to keep it very generic and very simple, okay? You've got a feature, and the feature is you want to test, is it Friday yet? Everybody wants to know when it's Friday, right? I certainly do. But hey, we're in hump day, so I'm a little positive there. Correct? But imagine you've got a feature, something along these lines. Is it Friday yet, right? So you could have a scenario or multiple scenarios, okay, to support this feature. But in this case, again, for the sake of simplicity, we've got one scenario. Sunday isn't Friday, right? Or you can say Wednesday isn't Friday, correct? Or given today is Sunday or Wednesday, in our case today. When I ask whether it's Friday yet, what does that mean? So I've got an application, I've got a user interface, and the system already knows that it is Sunday, right? And I perform an action, and that action is I'm asking the system, hey, is it Friday yet? And then the system should respond back saying no. Okay. The simplest of the example. All right. What you see in between where it says given and, it's kind of blurred a little bit, and it states optional. So you can have multiple lines in there. So given today is Sunday, and what else do you want to check? And yesterday was Saturday, and tomorrow is Monday. You could do that, something like that. Okay. Doesn't make sense in this example, hence I've left it empty. But in real life, you will see in reality where the scenario is written in given, hey, I want the system is in X state and Y state and Z state, or whatever it may be. And when I perform multiple actions, right? So when I was talking about Google example, there were two actions. I entered the data and I clicked the search button, right? So those are two actions, not just one. And then the results, correct? And you can have multiple sets of results. So again, if I were to use Google's example, then I should be displayed the ads on the top. The first three results should be the paid results. Everything else in the bottom are free results. And then everything on the right are also paid ad results and so forth, right? So you can test all of that. But the functionality behind the scenes is just one, okay? So that's what this is when you start questioning when you're going through grooming your user stories and you're creating this acceptance criteria is when you start, again, my terms, pressure testing, okay? Code and test level. This is what I've come up with. So this is your, if you're using Selenium and Cucumber, this portion is part of what is called a feature file. So imagine you're using Jira or Rally or TFS or whatever tool you're using. You have an acceptance criteria in there. You can literally copy paste that, or the developers can copy paste that into a text file and save that text file as is it Friday yet .feature. Okay, it's as simple as that. And that's what, let's see, is this right here, create test, okay? That's what that feature file is going to lead into. Let's see if I can get back to that slide, right? And when the developers run those feature files, this is what they get. This is a test and it's empty. So if you follow this right here where it says at given, today is Sunday, right? So here it is, given today is Sunday. And you have a function, right? And you are going to put in code, and it clearly says write code here that turns the phrase above into concrete actions. So you're going to write code here to meet your precondition, okay? Same thing goes here at when I ask whether it's Friday, and this is where your logic goes, right? So you're testing what is today, correct? And then is the result where it says I should be told no, if you remember correctly, okay? I had some more slides with the actual code in here, but I figured that it didn't make sense to go into that level of detail. But just from a high level perspective, I wanted you all to at least get a feeling of what this process looks like, okay? So we've gone through the story grooming phase. We've created acceptance criteria. We've created unit tests, and the code has been written. Okay, and let's assume the code has been written and all the tests are passing now. What's the next step? The next step is to deploy it to the production, correct? There's a way to deploy the code into production. One of that method is called a blue-green deployment. It's a deployment strategy. Don't worry about it if you're not aware of this. Just understand that what blue-green deployment strategy means is that in your production, you've got two sets of servers, identical servers. Okay, it's an identical infrastructure. So the hardware, both the blue environment and the green environment are twins. They mirror each other. Okay, same amount of memory, same amount of hard disk, RAM, anything you can think of, CPU power, all the good stuff. They are exactly identical. And you have your end customers, and you have your application deployed. Let's say you have labeled your blue environment as active environment, correct? So if you look at the diagram, the users, when they go to www.google.com, they hit what is called a load balancer or a router. And the load balancer's job is to route the users to the environment, okay? It could go to blue environment or the green environment. And in this case, the users are being routed 100% to the blue environment. So your blue environment is what is called an active environment, and you have green environment, which is called a passive environment, okay? And your organization is going through a version upgrade of your application, right? So you have a new deployment coming up. So the idea is that deployment happens into the passive environment, correct? So your version 1.0 currently working in your blue environment, your active environment, version 1.1 or version 2.0 in this case, let's say, is deployed to passive environment. And this is where testing happens in your passive environment. Okay, you can perform your sanity tests, making sure that the application is working. The users are able to access the application. You can run sampling. You can perform A/B tests. You can get some UX feedback. So if you all remember, Microsoft used to do this quite a bit. They would come up with power users, or in other words, beta testers. So if a new Windows version were to come out, they would reach out to Windows users and indicate them that, hey, would you like to participate in the beta testing of our upcoming new release? And if the users were to say yes, then Microsoft would send them updates. The users would be able to install those updates on their local machines. And all of a sudden, that particular user or a set of users are now So where Windows is at Windows 10 right now. Imagine if I were to be a power user or a beta tester, I have Windows 11. 98% or 99% of the Windows users are still using Windows 10. Okay, but I get to run Windows 11. And whatever I do on my machine is constantly sending data back to Microsoft. And Microsoft is gathering that data and trying to understand how Windows 11 is performing on my machine. Okay. In your example, you're not installing applications on your local machine, but you're installing application in what is the passive environment or the green environment. And you as a tester are given access to that green environment, and you go in and you perform tests. Okay. You can run manual tests as well as automated tests. Some examples of automated tests could be performance testing. You could stress the environment, do load testing and whatnot, and try to see how the hardware is behaving and how the application overall is behaving and whatnot, right? And you could also perform some analytics and whatnot. Okay. Imagine you did that in green environment and the test results are coming positive. Everybody gives a thumbs up. The next step is that the traffic is then switched from blue environment to green environment. So you change the tags and your green environment now becomes the live environment and your blue environment becomes the passive environment. Okay. And then you repeat the cycle. We're in agile model, so we continuously iterate through and enhance our application. So you have a new release coming up. Where do you deploy that, right? So here you are, a version upgrade, new deployment. This time you're going to deploy it into the blue environment, and you repeat the testing into production in the blue environment. Okay, so again, I wanted to focus a bit more on testing and not on the deployment strategy. If you just search on the internet about blue-green deployment, there are endless articles out there. But in the DevOps world, this is quite significant. A lot of, and when I say a lot of organizations, I can give you examples. Target uses this, Facebook uses this. Matter of fact, Facebook championed this. So does Amazon and others. I can also tell you some of the government agencies are also using this for those in DC area who is supporting federal government in their work. The agency I'm supporting also, I take that back. The agency that I used to support a few years ago used this. The current agency that I'm supporting is on its way to get to blue-green deployment. Okay. Another deployment strategy is using feature toggles. Imagine if you do not have two sets of servers, right? I mean, it's an overhead to maintain extra infrastructure. So some of the organizations may only have one set of servers, okay? And if you were to have new feature going in, what you can use is called a feature flag. It's a toggle. From people who write automated tests, they're perhaps familiar with annotations or parameters. Essentially, it's just a variable. You can set it to true or false. And when you deploy into the production, your application will read your feature. And if your feature has a flag saying false, or whatever you may want to call it, then that particular feature will not be available to your end customers. And similar to the blue-green deployment or the blue-green infrastructure, you can have a separate URL. So as testers, you can access that separate URL, which will make the new feature visible for you. Okay. If I were to go to google.com, I may not see that new feature, but as a tester, if I were to say google.com slash feature toggles, okay, I just made that up. Okay. And I said it, feature toggles is equal to false. Then I will be able to see the new features at that point, right? And because that URL is internal to the organization, nobody in the outside world knows that, and then they're not going to see those features. Okay, so that's what this feature toggles means by. And from a testing point of view, you can pretty much run through the similar tests. You may not want to run performance tests on a single line of infrastructure because now you're directly impacting the production servers. But you can run A/B testing. You can do the sanity testing, making sure that the features exist. I mean, imagine if you were to have a URL saying feature toggles is equal to true or false, you see the new features. And when you remove that portion from your URL, then you should not be able to see the new features, right? So there's your test as an example. Okay, so that's the shift right portion of testing. There is something called observability. It covers a lot more than monitoring into the production. Okay, and there are different parts of observability. I can tell you few government organizations are using observability. The organization that I'm supporting is on its journey right now to get observability, to make observability as part of their DevSecOps or DevOps journey through and through. Okay. On the commercial side, this is fairly, I shouldn't say it's fairly common, but a lot of known entities, for example, Netflix or Amazon, Target, Walmart, pretty much all e-commerce platforms, they use this technique. Okay. So let me start off on the left side. There's something called chaos engineering. Somebody put in the, actually, Cynthia mentioned in the chat window about prepare to recover if upgrade goes wrong. This is where chaos engineering or disaster recovery comes into the picture, right? Things fail, okay? Let's just go with that attitude. Everything we're going to build will fail. It's not going to last for infinity, okay? Something may have a long shelf life, but eventually it is going to fail. Same thing, same ideology somewhat applies to our digital space. That servers are going to fail. Your deployments may go bad. What do I mean by that? That you start off with a deployment and it did not complete. I can, never mind, that's just a bad example. I was going to use the Microsoft Windows example with the blue screen of death, but it kind of does not imply here. Okay. But just understand that the hardware fails, right? The new applications can guzzle a lot of memory. That's why these days we see servers running hundreds of megabytes of RAM, okay, if not gigs of RAM. I mean, our laptops, forget laptops, our cell phones have more memory than our desktops used to have 20 years ago or even 10 years ago, right? Why is that? So that we can do a lot more on our devices, correct? But after some time, our devices start failing. I mean, if you were to be using iPhone 2 or iPhone 3 today, kudos to you, more power to you, but I wouldn't be able to run Angry Birds on that, okay? because Angry Birds application has upgraded significantly, and the hardware won't be able to support. Right. So one example. So what is Simian Army? Netflix came up with this. It is actually, I believe it's a trademark, and or maybe they turned it into an open source, open license. So, um, so what they do with this particular program, they started off with something called Chaos Monkey, and they expanded into various different types of apes, and that's why now in their chaos engineering, they've got the picture shows the gorillas and the chimpanzees and every possible ape that exists on the planet, right? So they call it a simian army. And the idea behind that is they want to test the failures and they want to test the recovery. So they deliberately on their own go in and they randomly kill the servers. So if they've got 100 servers running their applications, they deploy a program called the Chaos Monkey that picks randomly certain servers and just kills it. I mean, imagine if you were to be watching, streaming a show or a movie using Netflix, and the server that was streaming your favorite show live all of a sudden dies. You're going to be pretty pissed at Netflix at that point, that you're paying, and every now and then their servers keep dying, right? So they have a way that if their servers die, they route the traffic, and they, if you were to be streaming video, you wouldn't even know what's happening behind the scenes. Okay. And they test that, they test the recovery. So not only they route the traffic to different servers, ensuring that your viewing experience is not jeopardized, but they also go back and figure out a way to bring that server online on its own without manual intervention. Okay, so a lot of automation that goes into the picture behind the scenes, right? And that's where the disaster recovery and the resiliency comes into the play. And this is not limited to the servers or the hardware. They perform this chaos engineering against a lot of different applications, against their databases, against their APIs, their microservices that they use, and in a lot of different areas. So all this happens on the operations side. It has nothing to do with the application. Okay, you as a tester will never realize that, but as part of testing in DevOps, I just wanted to, give you guys a brief introduction on that. Moving on to the middle column where you can perform A/B tests. I briefly alluded to this using your blue-green deployment or using your feature toggles. You can perform your A/B tests, your rollback testing. Already spoke about that a little bit. It is a whole lot easier to perform rollback testing if you were to have blue-green. If it's a single line of your infrastructure, there's a question on how do you go about testing your rollbacks, right? If you have deployed your application, you've had a progress up to, let's say, 60%, and then your deployment stalls for whatever reason, what do? You go back and figure out and deploy remainder of the 40%, or you pull out the 60%, and then you roll back into your previous version, right? So you want to test something along those lines as well. Performance testing and monitoring as well is part of this. If you have deployed your application into the production, you want to start monitoring the performance. I already gave you guys an example about that Honda Civic example. Okay. The extreme right column talks about predictive operations and insights. This is where if you are involved in a data science product or data analytics product, you're perhaps familiar with this. A lot of data can be gathered coming out of your production. environment, and you can perform all sorts of analytics, customer experience related analytics, your network analytics, trying to understand how the network is being routed and so forth, as well as the performance monitoring. Okay. So again, from the DevOps point of view, all of this is on the shift right area, falls under the ops bucket. Okay. So continuous testing using CI/CD pipeline. I kicked off the presentation saying no automation, no DevOps, right? So once the code is checked in, all the unit tests are run. Again, the unit tests are all automated. Once everything passes, you have the thresholds meeting, example, the code coverage, the number of tests are passing. That kind of results into the quality of your build. And if you have a automation server, for example, Jenkins, it will create a bundle or called an artifact, correct? And then it's deployed into your test environment where your functional tests, your automated integration tests will run. Okay. And then when on the QA environment, when you run your smoke tests, your regression tests, or your integration tests, again, you want to monitor some things, look at the KPIs, the percentage of the test execution coverage, of the requirements coverage. Try to identify the defects that you have fixed from a priority standpoint of view. Which defects have been fixed and how quickly have they been fixed. So the defect severity and defect age. And you could also perform exploratory tests. And exploratory tests, majority of the times are manual. Okay, hard to write, or it doesn't make sense from a cost perspective to write automated exploratory tests. Everything looks good on the QA and test environment. The automation server at that point can automatically deploy it into the pre-prod environment. And assuming that you have your automated performance tests, then you can check for latency and throughput in your pre-prod environment, and then finally deploying into the production environment, right? So you can leverage your blue-green deployment strategies or feature toggles and perform your sanity tests, your A/B tests. If you have blue-green deployments, you can also check on your performance and then perform chaos engineering if the use case makes sense for your business, and then also leading into the analytics, right? So you may ask, why do I have a continuous testing loop around this? So this, basically what it says is that every time a user story is checked into your repository, all these set of tests run in an automated fashion, okay? So you're testing continuously. So prior to check-in, you're performing your test-driven development, your behavior-driven development, and after, once you have checked in your code, then you again go through running your unit tests. Everything looks good. You deploy it into your QA environment, and then to pre-prod and prod, right? So literally at every time a a user story is created or developed, the code is checked in, you go through this continuous testing process, okay? Here's another diagram to perhaps help you understand even better. Developer 1, developer 2, developer 3, they write their own tests in their codes, they refactor it, they check it in your test environment. You're continuously running your functional tests, system tests, your integration tests, perhaps your performance tests. And then once everything looks good, goes into the production. So this is your dev portion, these two section, and this is your ops portion, and you're testing through and through, okay? Continuously testing all the way from the beginning to the end. And that being said, we are at the end of the presentation, and I'll open up for questions. I'm gonna go through the chat window real quick. But if you have any questions, feel free to, unmute yourself and ask away. All right. Wow, a lot of comments in the group chat. Maybe Cynthia, you and I can split this and divide and conquer if you want to go all the way to the top and come down till perhaps 7:30, and I'll look at the comments that came in after 7:30.
I think a lot of it was more clarifying of like Canary versus AB versus the blue-green deployments. Yeah, so like canaries are, so if anyone doesn't know, like a canary deployment is that you are just switching environments to your new system or your new deployments. You don't have a choice. The idea is that you want to like just see how it works with real user interaction, but there's a risk where things could go wrong. And so you need to make sure that, so you might have a hopefully limited downtime when you do Canary, but for blue-green, the idea is that you just have two parallel environments and you really just toggle the traffic back and forth between the two based on like, if there's a problem with the new system, you should be able to toggle the users back onto the other system and they're none the wiser. But there are points about like, how do you make sure that data isn't corrupted? Good point. That is why your team needs to think about that. It looks deceptively easy, but it's definitely not. Definitely needs a lot of preparation, really being conscious of the changes that you're doing so you don't run into problems like data corruption. So there is a question which is like, where would regression testing fit in and the frequency? I'll let Will take that.
Yeah, so if you have a minor release, and what do I mean by that? So if from a versioning standpoint of view, right, a major release is normally the number that may look like 1.0 or 2.0 or 3.0. The minor release could be 2.1 or 2.1.1, right? So let's imagine you have a production version 2.1.1 currently running, and you're going into 2.1.2. So when you're doing a minor release, 2.1.2, you don't want to run full set of regression suite. But let's assume you're going from 2.1 to 2.2 or 2.2 to 2.3. You may want to expand your set of regression tests to run. Okay, so the features that have been developed under the version 2.0, everything that is below or under 2.0, you may want to run that set of regression suite, correct? So for 2.1, going from 2.1 to 2.2, and you run the whole set of regression suite. Now, if you're going from 2.0, or let's say 2.9.9 to 3.0, that's a major upgrade, okay? At that point, you may want to consider running your entire regression suite.
There was a question around VB. Now, I don't know if you mean like VB. There was a question of if there was any BDD stuff that was VB friendly.
Oh, yeah.
Is there?
Yes. There is actually a great YouTube video. Matter of fact, I have it.
Yep. VB.
So, I'm going to, let's see, I'll just copy and paste it right here. So this is, they use a C# based program, and they use their build, deploy, test with Jenkins for Java and C#. So I know this isn't the whole Visual Basic or VB.NET, but C# as part of .NET can be helpful to you. Okay.
I'm not sure if it's free. Like I know there's SpecFlow, but I don't believe it's free. Like it's
Uh,
partially free.
are you asking for an IDE or are you just asking the basics?
No, SpecFlow is like the Cucumber library for.
Oh, okay, okay. Oh, that I am not sure of. Sorry, I old school a little bit on my end. Familiar with Java.
Yeah, that's fine. Like I wasn't sure like if they were like, I mean there is SpecFlow that is for C Sharp, but they want you to pay for it. Like
Yeah.
I actually think they block you if they see that you're trying to run it in SCI and you haven't paid for it. Um, so that is, I don't know if there's a freer version of it though, because we like free.
Yeah. Yeah. I mean, if you are a shop that's related with Microsoft, and Microsoft is known for charging, right? There's nothing free from Microsoft, except you may get some free version, some free trial period with their cloud, Microsoft Azure, but that's fairly it. I also wanted to mention that I noticed there were a few questions around the deployment strategies. I would recommend look up the AWS documentation. They have some free articles. Well, actually, all their documentation is free. And they have a lot of white papers and articles which are available to everyone. And just type in AWS Blue Green Deployment or AWS Canary Release, and you will get some great articles, and that way you can familiarize yourself into how those deployment strategies fit into the DevOps world. Okay. I also want to mention that there are some free courses from AWS. I'm not pitching anything for AWS here. I am AWS certified, and I would tell you that if you have cloud infrastructure, your DevOps journey will be a whole lot smoother. And you, well, let me not use the word smoother. The possibilities will be a lot more. You'll be able to do a lot more using the cloud infrastructure versus the constricted on-prem infrastructure. So when it comes to DevOps and anything related to digital development, they have a lot of articles and very much relevant. So I would encourage all of you to just search using Google or Bing and whatever you use, and try to familiarize yourself with that.
It's like unrelated to what we covered tonight, but since this is my first time here, I figure I'll ask you guys: are there any good resources for like? I feel like I've looked for like any kind of like even college programs specific to QA, and there's nothing that I can find. So like, where do you guys go to try and like keep up on stuff? I do have Ministry of Testing, like the podcast, but a lot of it's over my head right now. So like, how do I get into all of that stuff? Where should I go?
Yeah, I could tell you there are some private entities out there. Some are pretty reliable. I don't want to paddle in for anyone here, but I'm happy to share some URLs, uh, you know, as a follow-up.
That's why we have this. Great
There.
yeah,
There.
go ahead, Nancy. Yeah.
I was just going to share that there are a handful of conferences that are happening. I think it's called Star East and Star West, and they are very focused on QA strategies. And a lot of folks from our organization attend every year. And at this point, I think East West doesn't matter because it's all virtual. So you may still have an opportunity. You probably just missed one that was just a few weeks ago. But those are usually our folks come back with good deal of information, which is mostly, oh, we got our shit together, and that's great to hear. But if you're starting up, it will be quite informative for you.
I don't know if Jean's here, but Jean helps with stars, so
cool.
those conferences. I actually just posted off our dcast.io website. We know this is a big question everyone asks. So we have listed here some other resources that are both local and more global that you can use. And don't feel overwhelmed because it is overwhelming. And there's no one right path to this career. And as actually as Dhaval has actually pointed out, like it's really expansive. Like don't try to tie yourself really into a bubble because really this whole career path and scope is actually expanding.
Yeah.
Especially with DevOps being in the whole mix. Like you thought you were okay doing this one little bit. Guess what? Not anymore.
Yeah, we're like waterfall right now and we're switching to agile, and I was at least a little familiar with it from other friends that are actually developers and not QA, but we have some growing pains there. And then it's just like even this whole presentation, it's glaringly obvious how far behind it is. And it's because it's, you know, it's for a government project, right? So they've been maintaining it for a really long time, and we do everything manually, and it's just there's a lot of room for improvement. So I'm excited.
Don't worry. In next year, you're going to hear someone say the exact same thing. I've been in the industry for like over 10 years, and every 3 months I hear someone say, I'm moving into Agile. So this is like 10 years almost of hearing people say this. So don't feel bad. You're not late to any game. Everyone will come to the game. So don't worry.
Thank you for the resources. And that was a very thorough presentation. So thank you for that.
Yeah,
There's
I'm
a lot
glad
of
you
really
liked it.
good takeaways for, even though some of it I don't know if we could directly apply like immediately. It's helpful so that I know as we're, because they are starting to make changes now, at least I'll have a better idea of where we could go.
Sure, sure. And Cynthia, I'm not sure if there are more questions, but you know, I'm happy to answer if you have any questions. Feel free to hit me up on LinkedIn if you have any questions. And I don't know if Cynthia wanted to go through like any other resources, job openings, and whatnot. If folks don't have any more questions.
I'll wait for a couple of seconds for anyone to open any questions they also may have. Okay. Just like so as well, because this is a resource, if you do have any openings or you have any needs, please feel free to let us know. We'll be happy to broadcast that. So that way people find the right jobs for them, right? So we're always fishing for talent. I know all of us are fishing for people, and we're probably all trying to figure out who wants me. So if you are looking for something or you have a job opening, let us know and we can try to make sure that you're connected in the right way.
Okay, Cynthia, I can stop sharing and you can take over from here. And then, you know, you could do whatever you need to for concluding.
I was gonna say, like, thank you.
Oh, I'm glad.
Yeah, thank you.
Hopefully people found this useful. And yeah, I've been involved with the federal government for a long time. Pretty much all my career has been with the federal government as a contractor. So even if you were to have questions related to testing, whether it's the technical aspects or the processes or the flows, you know, happy to answer questions anytime. Just send me a message on LinkedIn, and you know, be happy to help anyone and everyone.
Yeah, I'm going to hit you up. We're at a point where we are starting to build some metrics around DevOps performance in general. So I'm looking for ideas.
Okay.
Okay. Well, if that is all, then I wish everyone, you know, be safe, be sane in these crazy times. And if you do have any questions and you need help reaching out to Dhaval, like just let us know. We'll make sure that you get connected. His LinkedIn information is on the meetup if you want to, you know, connect with him and message him that way. But thank you very much. This was a wonderful presentation, and hopefully we'll see you all at the next one.
Yep.
Thank you so much for
Thanks,
setting
Al.
this up.
Yeah. Thanks all. Stay safe.
Thank you.
You
That
too.
was awesome.